presenter coming to the mic here is Mr. Juan Gonzalez. Juan got his Bachelor's of Science and his Master's degree in Chemistry at SDSU. He specializes in nanochemistry and device applications such as thin-film solar cells. He currently teaches high school science, math, and sustainability science. Tonight he'll be talking about future megatrends. So please put your hands together and welcome Mr. Juan Gonzalez.
All right, hope everyone's doing well tonight. Thank you for the warm introduction. My name is Juan Gonzalez. I'm going to be talking to you guys a little bit about the future today. I spend quite a bit of time thinking about the future and what the future is going to turn out to be like, and I'm a big supporter of the Zeitgeist movement because I believe that many of the solutions that the Zeitgeist movement offers really do try to get to the heart of why we have some of the emerging problems that we have. I'm going to talk to you guys today about 3 megatrends. And then we're going to talk a little bit about how the Zeitgeist movement doesn't necessarily say that it has a silver bullet, but certainly wants to bring ideas to the table that could address these problems that are going to strike our society in a very big way. All right, so one of the megatrends that I'm going to talk to you guys today about is about world population and where Earth will be within the next couple of decades. The next megatrend is on climate. And what does the number 450 mean to you? And finally, because the Zeitgeist movement does also center a lot about discussions on economics, I will, for a little bit, talk to you guys about where the big trends are within money and labor, and what that might mean ultimately for you and me, who are Joe Schmo, right? Okay, well, if none of you have ever seen this graphic before, this is a pretty common graph that's published by the United Nations, and what you can see from it is that there are 3 lines that are stemming from this point. This is about where we're at today. If you weren't aware of this, we crossed into the 7 billion person mark about 1 year ago, on November of 2011. So we're obviously well above that now. This is again the United Nations estimate. And when you really put everything in perspective, you simply take and look back in time to around 1960, where many of you might have actually been alive. There were only 3 billion people on the planet. And so within only 2 generations' time, we've been able to add 4 billion people, and with an increasing rate. The rate at which we're adding people to the planet now is somewhere in the order of 200 million per year. And to also put that in perspective, it took us about 10,000 years to be able to add the first 200 million people. So you can kind of do the math how fast things are starting to progress. And so we have 3 scenarios that are outlined for what the world population could be like. And in an optimistic scenario, we will hit somewhere in the 8 billion mark and then start to level off. That's the optimistic scenario. Probably the more realistic one is the orange one, and I'll tell you guys a little bit about why it's like that, and the one that's going to spell, well, kind of, I don't want to sound so doomsday. It really is kind of a doomsday if we step on the red path. So in order to find out why we are there, let's go take a little trip through time. And these, what's it called? What I'm going to show you guys are some live statistics, basically statistics in action, I should say. These were compiled by Hans Rosling, a very, very gifted researcher from Sweden, who's been studying the problem of world population and why world population is the way it is. So, as we hit the play button, one of the best pieces of data that we have throughout the last 200 years or so is actually population data. And what we can see here is we have a steady climb of these dots over here. These are represented by Eurasia, Western Europe, and then there's the United States. China over here with the big red dot, the size of the dot, of course, meaning the relative population. And look at what's happening as we've crossed over into World War II era. All of a sudden, China's coming up, and now the life expectancy of the average person as we reach the modern era is somewhere in the neighborhood for us at around almost 80 years. And what you'll also notice is that the life expectancy has remained relatively short, only about your mid-40s for a place, I think that's Sierra Leone, if I'm not mistaken, Congo. And but all the blue dots representing pretty much countries within Africa. So what are all the other countries except Africa doing to increase their life expectancy? And if their life expectancy is so low, then how could they possibly be contributing to overpopulation? Well, if we then simply look at the number of children per women, we can get an idea of where. Let's see. Go ahead. And there we go. Alrighty. And let's bring this back in time to the year 1800, when the mean number of children was somewhere in the 5, 6 in the year 1800 in the pre-industrial era. But as soon as we get some data on, as soon as we let the data fly on that, we find that most of the countries have not yet entered the industrial era, but now all of a sudden countries in Western Europe, and then there's the United States now entering the Industrial Revolution, and all of a sudden modern science is taking off. And we start to see a steady decline in the European countries as well as the United States in the average number of children per woman, coming down to nearly 2.1 or so. Even China, oddly enough, as maybe many of you had preconceived notions that it's actually China that's causing all of these world population increases, when in fact it really isn't. What we find is that the total number of children per woman is the highest in the least developed, the poorest countries in the world. Finally, let's see. Let's go to child mortality. So the thing is that when we look at the right now we have very limited data, of course, coming through the 1800s, but as we kind of see what happens with what's called child mortality over time, child mortality starts to actually decrease quite a bit in all the industrialized, all the technological countries. But still, before we get into modern medicine, all of a sudden now we're getting into the area of antibiotics, into World War II, and now we're starting to get some third world data, and we start to see another steady decline in the number of infant mortality rates. Keep in mind that these are the same countries that are also decreasing their number of kids per woman. Yet now in the year 2011, if you happen to be a woman living in the Democratic Republic of Congo, you expect somewhere in the, well, almost, actually, if we can go a little higher, yeah, this is Sierra Leone, that's a little higher. That's almost 200 for every 185 babies, or sorry, for every 1,000, 185 will die. So that's somewhere almost a 20% infant mortality rate. So, but that also means that if they're having somewhere in the 4 to 6 number of kids, then there's 4 kids that are living to adulthood, and that's ultimately why we are starting to see such huge spikes in world population numbers. So this this doomsday scenario, if we don't manage our resources in the correct way, we will hit well over 8 billion and down to 9 billion by around 2050. And so it's that much more important why we have to have intelligent management of some of our resources and access to technological, basically access to technology and education. Because as I said, most of the growth will technically be occurring in the developing countries. It will actually surprisingly not occur in Europe. It will not really occur that much in the United States, and to some extent in Latin America. So, should we blame it on any of those? It actually turns out, actually, as much as you would want to, you can't blame it on those people. Okay. All right. So now I want to talk to you guys a little bit about the climate. And as you guys might recall, I mentioned a special number called 450. We'll get to what 450 means in a second, but this particular prediction was put out by the National Education Council, and they come out with reports about every 7 to 10 years or so. And the last one just came out in 2012. And the National Intelligence Council it's a council of some of the world's top leading scientists. They're assembled by the United States government, and they basically just sit around and look at all the different megatrends that are affecting different sectors of the world, such as the economy, such as population growth, such as energy, and it's completely nonpartisan. So they just simply get their data and say this is where we think the world is heading. And they've actually never really been wrong about any of their predictions, with the exception of this year. They were not able to predict the Arab Spring and the various revolutions that have taken place in the Middle East. But on just about every other front, they've pretty much nailed it since they started doing this back in the late 90s. Now, if you didn't realize this, if you happen to live in a more technologically developed place or region of the world, you always require more energy. And so there's nothing wrong with necessarily requiring more energy to carry out a lifestyle, but it's simply more of a question of where is it going to come from. Because where it comes from ultimately affects everybody's standard of living, not just the people who live in the first world. So we've been increasing the amount of CO2 that goes up into the upper atmosphere for or actually only a relatively small amount of time in a way that's changed changing our climate in very profound ways. What maybe most of you guys didn't know, or maybe you did, is that about 40% of all the CO2 emissions are actually due to energy production for electricity, and that almost always invariably comes from coal. So it actually doesn't necessarily come as much from transportation, although they account for somewhere like 11 to 20%, depending on where you are in the world. Okay, and I wanted to share with you guys one more statistics in action about how much CO2 we've been putting into the planet as a function of how technologically advanced you are. Hence, in other words, what the income per person is. Again, it's basically the rich countries, the countries in the middle, and then eventually we bring the lesser developed countries. And when we look at it from the linear scale, it doesn't actually look that much. It doesn't look like there's a huge difference, but the thing is that the difference between one of these countries, as now we get into the modern era, is a difference of about 100 times or more CO2 emitted per person than it is if you were somebody living in, say, a country like Bangladesh. Now, the number 450 will mean a lot to you because it correlates completely with how our global temperatures are rising. And right now, this is as of this year. This I actually took this month from the NOAA website, and the CO2now.org is their own is a project to bring a lot of the climate data to the public, and we're increasing the amount of carbon dioxide by about 2.1 or so parts per million annually on the average. There is fluctuation, obviously, depending on the time of the year and where you take the measurement. But the thing is we've never been quite that high. And 450 parts per million, that's the concentration of CO2 particles in the air for every million other particles that there are, brings you to a climate that no human was around to ever see. This is a picture. This is just a picture I jacked from the internet about the Pliocene era. The Pliocene era was a geologic epoch that took place between like 5 and 3 million years ago, basically before there were humans. So for anybody who's really trying to criticize that, it doesn't really matter how much CO2 goes up there, that's going to change when we get to 450 parts per million. Pretty much every serious climate scientist is in agreement that you've kind of gone over this tipping point where now you are in this distinct geological era that is going to be called the Anthropocene, because it's a geologic era that got to be that way due to due to the activity of humans. Now, getting to the new kind of pseudo-Pliocene is going to be very, very, very bad, because once we're well into this new geological age, it's actually probably going to be pretty nice climate on the whole. However, it's the amount of transition that's going to take place that you're going to see such violent swings in the climate that's actually what we should be really concerned about. Actually, let me come back to that in a minute. Okay, actually. Oh, okay, that's right, I changed it. Okay, now the question is, how did we obviously get that way? And one of the reasons we are in such dire straits over that is simply due to the availability of cheap oil starting somewhere around the Industrial Revolution. It's pretty much what allowed the Industrial Revolution to take place. However, in the early 2000s, most people would have told you that that study this issue is that we're starting to peak, or we've already peaked with the amount of oil that we can take out of the ground. So it's now costing more oil than we can take, and we need to invest more energy and more oil to be able to get increasingly less and less amounts of oil out of the ground. And if any of you guys remember, back in 2008 when we crashed, it was because oil was really, well, among other things, the commodity of oil had ballooned and then all of a sudden came crashing. Now in the United States, there's been this really brand new boom in energy production due to shale oil. And this is going to do absolutely nothing to really help to come down with our CO2 emissions. And so many of the politicians are talking about targets for fossil fuel burnings, but really we are so close to the tipping point that even what they're proposing, making cars get 30 and 40 miles to the gallon mandatory by the year 2020, this is going to turn out to be just a drop in the bucket. It's into quite possibly an irreversible climate. Now that's also affecting a lot of our water resources. And if you guys didn't know, 70% of our Earth really is covered by water, but only about 1% of that is actually drinkable. It's only potable. Only about 1%. And an increasingly a large proportion of that 1% is basically becoming unusable because of things like pollution and mismanagement of those particular water resources. Now, the National Intelligence Council also talked about one of the consequences of climate change that could lead to upcoming water crises. And there's really no one thing that I think could really wind up or help to focus the mind more than a water crisis, because it doesn't matter, you can keep people unemployed, you can keep people in poverty, you can take away technology, but as soon as water runs out, that's really spelling out disaster within days, not weeks or years. And some of the and if you'll notice here, the United States, the rain belt is one of the most at-risk places within the United States, and there's clearly lots of places within the other part of the hemisphere. But what will happen in the United States will ultimately affect most of the people in this room. And the Ogallala Aquifer in the Midwest is pretty much where most of the water for all the crops that are grown in the Midwest are drawing this water from. Now the blue borders, or rather these are the outline of this underground aquifer clearly spans many states, and the thing is that there hasn't really been an adequate inventory of this particular aquifer, so we know that it's depleting very, very rapidly, but we don't quite know the exact amount of water that's left. So when the water runs out, we can't tell if it's going to run out in 10 years or it's going to run out in 20 years or 30 years, but it's going to run out. But it's going to run out pretty much within the next couple of decades, especially if it keeps getting drawn at the current rate. Let's see. The last megatrend that I wanted to talk to you guys a little bit about is where the jobs are going to go, because this kind of affects most of you, since we still live within the monetary system. And James Wolfenson is a former World Bank president. He gave a lecture for graduate students at Stanford University back in 2010. And in this lecture, one of the things that he emphasized is the shift that's going to be happening within the monetary system. And the monetary power will shift away from the US and Western Europe and will shift into Asia and other market economies. And while that might seem kind of cool for them, or they'll have their day in the sun, what we start to see is that the kinds of jobs that are going to be available over time are going to spell out a much lower quality of life for people on the whole. For example, if we look at the way that automation has taken over the most common sector of the economy pre-industrial era, which was agricultural, we find that most people worked in most people worked in the agricultural sector. After the Industrial Revolution, you start to completely deplete that workforce, because now you're moving them into the cities, and that's precisely what's going on in all the urban, all the developing countries all around the world. if we go into manufacturing, which was once thought of as the easy way into the middle class, we find that the same trend still applies. Between 1998 and 2002, we increased production while at the same time we decreased the workforce because due to better processes, better engineering, better automation. But even as automation has resulted in fewer jobs in the United States, many of them have been imported into other countries, such as China. Most of the iPhones, actually, no, I think 100% of all the iPhones, what am I saying? I think are actually made by Foxconn at the big mega plant in Asia and in China. And this has been kind of in the news of this particular plant because of all the violations with labor agreements and. But the moral of the story here is that even though these manufacturing jobs that were once considered safe in the United States, that went to other countries, and everybody got all riled up about them, well, even now they're being completely subjected to automation themselves. Foxconn is the world's largest electronics manufacturer, and it is. And when this announcement came up back in 2011 that 300,000 robots would be employed, and by this year, 1 million robots making iPhones, well, that means you don't really need humans that much anymore. And that's kind of the paradox of where we are today. Productivity seems to be going up and up and up and up. We seem to be able to make goods faster and faster and faster. Technology continues to improve and improve and improve. But the monetary system has kept us, at least most of the planet on the whole, with relatively low wages. So although we can get the goods really cheap, we really can't afford a good standard of living, even once we live within the developed countries. And of course, if you live in a country like Bangladesh, the disparity is even larger. But this is one big megatrend that you're gonna see, that as the number of jobs in traditional sectors go away, every job that's going to be available that can't be done by a machine yet is service-oriented. And what happens is that most of the new jobs that will come online can be done by a high school equivalent, or basically by a high school diploma, not educated labor. So over time, we need less and less educated labor. We don't need necessarily more, because, well, at least as far as the way the workforce is structured. Now, certain professions will be very much in demand for a while, such as healthcare and geriatrics, which is where personal care service is. But even over time, we might be able to envision a society, maybe by 2050, around two generations' time, when even those professions, those service-oriented professions, those creative professions that we thought that couldn't be taken away by machines, ultimately we would be competing for that labor. And so, to close off, I want to give you guys a little bit of a perspective of where we've been in terms of a society, and where we can, so long as we look at the problems with a holistic lens, because we can't just attack a lot of these problems, a lot of the global climate problems, a lot of the global labor problems, without looking at the entire system as a whole. So if one country simply gets its act together, but the other country just across the border doesn't, that will create actually greater disparities, greater strife within classes. And what the Zeitgeist movement ultimately advocates for is a complete inventory of the planet's resources, so that we know how to appropriately allocate them to be able to address some of these problems without simply depending on market forces to get their act together, or what the consumer supposedly wants, because ultimately that's not going to fix anything, because that's ultimately how we got to this mess. I know that I've said a mouthful, so I'll go ahead and conclude right there. And thank you, everyone, for your attention. Thank you.